a world full of resources, there's a material that everyone is familiar with. It is a very strong material that can be used to make a lightweight structures that are more durable than traditional materials such as wood. A mix of common aggregate that binds sand and gravel particles with water to form a hardened cement-like mass. Each combination make a product with unique properties. For example, some materials tend to make a product denser and more durable than others. What we are talking about is concrete. Recently, the second most widely used material, which has been in use for centuries due to its original blend of physical and chemical qualities. What happens when fiber is added to this so-called blend? Well, the answer to that question is nothing new. Mix concrete with different fiber materials, and what do you get? A stronger structure. Hold on. Demonstrating what I'm talking about is much easier. Let's head over to DPWH to meet the rest of the researchers. Concrete is weak in tension and has brittle characteristics. Compared to other building materials such as metal and polymers, concrete is significantly more brittle and exhibit poor tensile strength. The use of continuous reinforcement in concrete, aka reinforced concrete, increases strength and ductility but requires careful placement and labor skill. Alternatively, an introduction of fibers in discrete form in plain or reinforced concrete may provide a better solution. Here's our team in action.
Hi, we're currently conducting an experiment, but I'm here to share some thoughts about our research on the durability of fiber-reinforced concrete made from Coco nucifera, zeamice, and Musa textilis. So what is fiber-reinforced concrete? It is a type of concrete containing fibrous materials which increases its structural integrity. In this study, we measure the durability of fiber-reinforced concrete. The durability is the resistance of the material against deterioration caused by physical, chemical, and biological agents acting in specific environment. But what really is this study for? Is fiber reinforced concrete? How will that contribute to the community? Well, what's good for the goose is also good for the gander. This study can be beneficial and significant to the public. The result of the study could help find a new construction product that can prevent the public from receiving huge amount of damage from the future calamities. To the community, the result of the study could help the community find a new use for Coco nucifera, zeamice, and Musa textilis. To the bricklayers, the result of the study can provide additional knowledge to the bricklayers on how to improve the quality of their concrete. And lastly, to the future researchers, this study can be used as starting point for the new research or to check the validity of other things in the same field. Several studies of the strength and behavior of natural fiber reinforced concrete have been published in recent years. Since fibers are abundant in many developing countries, more in-depth research should be dedicated to the numerous problems related to their utilization. This research study presents a critical review of the utilization of fiber-reinforced concrete and the effectiveness of using fibers in concrete in terms of their strength and its durability. These tests would determine the durability of fiber-reinforced concrete made from coconut, corn, and abaca fibers. But wait! How fast will we get there? How will it be done?
The study's general objective is to assess and evaluate the effect of fiber when reinforced in concrete, specifically to determine which fiber amalgamation is most durable. This is achieved through the following methods. The procedure entails the procurement of materials, their preparation, and the proportioning of mixed materials. In addition to the mixing of cement, a total of 27 cylinder test specimens were produced. The testing of specimens was conducted through the comprehensive strength test in the Department of Public Works and Highways. Before the testing, the researchers asked permission from the department's office by sending a communication letter, which was approved by the latter. The data was collected on April 29, 2022, with the help and guidance of the department's personnel.
the specimens, the result obtained each objective were as follows. In the procedure, there are three mixed proportions used: 1.5%, 3%, and 4.5% fiber reinforcement. The first objective is to determine the mixed proportion most effective in fiber reinforcement. The results revealed that 1.5% fiber reinforcement is the most effective, as it has the highest average pressure applied. The second objective is to determine the most effective fiber used in the reinforcement of concrete. In the procedure, three fibers were tested: abaca fiber, coconut fiber, and corn husk. The test conducted revealed that abaca fiber is the most effective in reinforcement in concrete. Let's take a look at the graph. The graph shows the result of the test. Based on statistics, all the treatment of both corn and coconut fiber had the same effect. Only abaca had a significant effect in the durability of the concrete.
To conclude, the researchers made fiber-reinforced cylinder concrete as test specimens with 3 replications and 3 mixed proportions: 1.5%, 3%, and 4.5%, using 3 fibers: abaca, corn husk, and coconut. This study was conducted through a comprehensive strength test in the Department of Public Works and Highways. Results showed that among all the fibers and mixed proportions tested, 1.5 abaca fiber is the most durable fiber amalgamation as reinforced in concrete.